Graded Math 3, Dilations, 8.1, essential question, what does it mean to dilate a figure? Goals, identify and perform dilations, solve real-life problems involving scale factors and dilations. Okay, I'll stop with that. That's just too much. 15 seconds of my life I'll never get back. Guys, we're going to start talking about this idea that you just already dealt with right here. Similarity, kids. This whole chapter is going to be about similarity. Okay? Similarity meaning same, what?
Same shape, different lengths.
Yep, so same shape, but
Different size.
different sizes. That's going to be kind of your whole focus today. So, 8.1 starts out with this title. It says, hey, we're going to deal with dilations. Now, I'm pretty sure, I think I know the answer to this, but most of you kids have been to the eye doctor before, right? Have they ever done something to your pupils before? Why would they do that?
So they can see inside of it because it makes your pupil big.
Yeah, so it makes your pupil bigger. The pupil being which part of your eye?
Black part.
The little black part. It's sensitive to light. If the light's on, the pupil is
It's smaller.
smaller, but if the light's off, it gets what?
Bigger.
So when we dilate your eyes, the pupils get what?
Bigger.
Larger, allowing more
Right.
light to enter your eye. Let me talk about the size of your pupil when the light's on and the light's off. Typically the same size,
No.
same shape.
Yes.
So there's kind of some relevance to this idea of dilation, right? Dilation means we're going to take a shape and we're going to make it either bigger, keep the shape the same, or make it smaller. That's exactly what we're doing today, kids. Dilation right over here says the following. A dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed what? Point C. You're going to see a lot of drawings. I'm just going to make a sketch here. You might have a point C. How many of you guys are taking an art class that has drawing in it? Have you done any perspective drawing that talks about vanishing points?
Yes.
Okay. If you can think of point C, for my art people that are here, if you can think of point C like a vanishing point when you do perspective drawings. Who has art today? Anybody have art today?
I can't see.
I had art.
You had it already? I was going to say, go down and tell Miss D we were talking about vanishing points in the math class today. But it'd be like this. If I had a small, I'll do the best I can here. I'm just going to make some squares because we talked about squares being the same. Here's maybe one square. And then maybe here's a different size square that, how do I do this? If you would line points up, kids, watch what I do. First of all, you guys agree that those are the same shape, but the size is different?
Yeah.
If I would draw like a point, or if I would draw a line that match up the corresponding points, so for instance, maybe right here, this point matches the top left point here. And when I draw that line, it kind of comes together at the point C. C is the point where everything goes from right there. So kind of the same thing here. If I drew a line from this point to this point that matches, I'll do my best. I'll do my best. Oh, Lordy. Pretty close, right? You get the idea here? Okay. That point C, if you draw segments from an original figure to an image figure or vice versa, all these lines are going to meet at what's called a point C. Okay, it's called a fixed point that all your dilations are going to originate from. Okay. Think of a flashlight. Think of a flashlight. Okay. The flashlight, the bulb is right in there, and then that light kind of does what?
Projects.
It projects out like this way. Okay, the further the light goes out, the wider it gets. You ever taken a flashlight and held it like up and down to the flat surface? The closer you get it to the surface, what happens to your area? Smaller and smaller. Pull away gets larger and larger. Okay, and all that light is coming from here. Closer you get to something smaller, but if you let it project a long ways away, it gets bigger there. Okay. I think as dilations, this is how I kind of think of it. It's like either doing this. It's like you're zooming in or zooming out. Dilations are like zooming, okay? Makes sense? Okay, so center dilation up here, which point is the center of dilation? When we talk about dilations, especially in the coordinate plane today, usually the dilation is going to center around or originate from a fixed point, usually the what? Origin. Not all the time, but most of the time, your center is going to be at 0, 0. And we're going to look at some examples like that, okay? Scale factor. Scale factor simply means it's the image size divided by the original size. So if I say, hey, take this shape and double it, what's your scale factor? 2, okay? So if I say triple it, what's the scale factor? 3, okay? We'll talk about what that means, but there's a rule for finding scale factor, and I think this is pretty important. I think you should highlight this. Rule for finding scale factor, and we'll look at examples, is to take an image length and divide it by what? What's it saying there, kids?
The original size.
Gosh dang it. Take the original size and divide it into the image size. So here's the deal. Let's say one side of my die is 1, or let's go 2 units. Let's just say this is 2 units long. And let's say if this is 12 units long. Okay, this is the image, this is the original. I turned this into this. So the image length is 12 units long, and the side that corresponds to it is 2 units long. What's the scale factor?
6.
Okay, so you take the image length, which is 12, the new one, divided by the original, which is 2. What if it was the other way around? What if I said, take this and turn it to this?
0.5.
If this is 2 units long up here and this is 12 units long, what would 2 over 12 reduce to? 1/6. So a scale factor can either show enlargement or it can show reduction. Kids, enlargement means that you're going to have a scale factor greater than what? 1. A lot of times they talk about the K value. The K value in this right here, if you're ever dealing with scale factor, something's going to get larger if the scale factor is greater than 1. So you want your K values to be greater than 1 here typically. And then a reduction like a half or a third or a fifth or 4/5
17/5.
or 0.31741125 or 0.314. Any dilation that has a scale factor between 0 and 1 is going to be what? Makes it smaller. Okay, so I always say that a reduction happens when it's between what? Okay. Now we're going to talk about what happens. We're actually going to look at what happens when a scale factor is negative. We'll talk about what's going on there. I think you guys will see what's going on. Really, I have a question. Can you guys count?
Yes.
No.
This is like the thing we did last year with like whatever linear and the taxes thing you said, like in a bank account.
Yep.
What?
Yep.
Like how it's like less than 1 or bigger than 1.
Yep. It's like growth or decay type thing. Yep.
I got no idea what you're
Yeah,
talking
no, I know you just.
Jacob, I'm glad to hear you say stuff like that. That just
I
makes
don't
my
remember the
day.
equation, but I want.
Makes my day that you understand that though, or remember stuff like that. Yeah, will you use it every day? No.
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 But could it come up? That's funny. Yesterday, I just did some refinancing on our house yesterday on my day off. You want to hear about this?
Sure.
I was shopping at banks, looking at interest rates, and so like our house payment, it's kind of hefty during the months, and so I was like, well, with the time of stuff, like our house payment is like $1,345 a month. Okay, at the interest rate we're at. So I applied for some new interest rates, just looking around. And I was able yesterday to find some better interest rates and lower my monthly payment by $172 a month. That's a pretty good deal, right? So my K value was greater or less this time? It's all relative. I wish I could teach you a class on saying we're buying a house today. Have you done financing like that? Financing houses in classes?
I think that would be very helpful because honestly, I'm probably just gonna.
They don't tell us how to pay
Yeah,
taxes.
yeah, taxes is like gonna be the hardest part. I don't know how to do
Like,
it.
Not really.
taxes or
Honestly,
cars.
People always get mad. It's not hard.
how to file for taxes is not that hard, really. What I would encourage you guys, I would encourage you to go to somebody because I'm going to be honest with you. There's things that I do as an individual that if my accountant didn't do it for me, I would have missed it. So But it's not too bad, really. Maybe I should take some wind time and teach you that stuff.
Yeah.
Yeah.
We literally have a finance class.
Wind
that
time
everyone has to
Yeah, we
take.
have finance.
Everyone has to
Do you
take.
guys talk about how to fill out tax forms there and stuff?
I don't know.
Because really, they just need to get your own paper and you need to
I
sign
feel like
it.
it's helpful
That
for
was a
math
Bergmeyer.
teacher to teach that.
Oh,
Well-
gosh.
Have they talked to you about like withholdings and dependents and stuff like that regarding taxes and what you should do given your financial income and
I don't know. You take it next year, so.
really?
Or senior year. I don't know.
Definitely take it. Definitely take it. There's a lot that goes into it. So
It's mandatory. We all have to.
really? Okay. Well, I'm gonna stick with the dilations part here, but that's a great little interjection there, Jacob. So increase, decrease, K values more than one, increase. So here we go. Rules about dilations. First one says this: if P is the what, kids?
Center point.
If P is the center point, so if P happens to fall right on the center, then it says P is equal to P prime. I'll show you what this means here. Let's say there's a dilation here, and that point right here, let's say we're going to dilate this square, but this is really saying this point C, if this was also point P, if I made this bigger from this point, kind of looks like this, okay? It's kind of like saying, if I matched up my points, and I'll show you what this means in a second. It's just simply saying this. If one of my points, or one of my vertices of a shape is on the center, or point C, then this point C is the same as the point P, which is also the same as the point P prime. And I'll tell you what P prime and all that stuff means here, okay? All this is saying is this: if this is my center of dilation and one of my points of the shape is on that these 3 points are the same exact coordinate. Now, if it says if P is not on the center point, then the image point P prime lies on the line CP, okay? What this is saying, suppose that this is my center. Maybe there's a square here and a bigger one here. Okay, that's not a very good drawing. But what they're saying is if this was P, you agree this is the bottom left point of the little square? So what point would this match in the bigger square?
P prime.
P prime. So they say, okay, if P is not on the center point C, they're saying if I would draw a line from P prime to P, that line would go through which point? Would go through C. Now I know that's not the best drawing in the world, but they're saying suppose P is not on the center here, then P prime would be on this line right here like that. Okay? Guys, last thing you need to understand about dilations, it says all measures are, angle measures are what?
Preserved.
Okay, so what's true about all the angles in this square right here?
They're all the same.
And what's true about all the angles
They're all
here?
the same.
So are the angle measures changing? The only thing that's changing in dilations is
The side.
the sides. So I'm going to make a note here. Sides, not angles. Sides are the only thing that what?
Change. Get longer.
Yep. Sides are the only change right here. So if you can remember those rules, if one of my shapes falls on my center of dilation, then P and P prime will also be there. But if P is not on the center, then P prime, P, and C all lie on the same line.
These notes are in color.
Sweet.
Then that's two things though.
That's all right. I kind of like the color, don't you?
Yeah, and it's like not like it uses much ink because it's just the graph line.
Yeah. All right, let's roll,
I can
kids.
actually read the numbers fine.
Are you good on the first page? Okay, page 2 then. So it says identifying dilations here. I'm going to blow this up here quickly. How do I make this? Oh, is it this one? There we go. Okay, identifying dilations. I'm going to blow this up quickly, kids. First thing it says right here, it says find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. Okay, here's what I need to tell you. Okay, anytime, well, first of all, we're talking about two triangles, right?
Yeah.
Okay, first of all, where's my center of dilation? Which point? Okay, C is, this is your center right here. Whoops, yeah, I'll write it in there. What the heck? That's my center. Okay, now, we have points that are P and P prime. Okay, one of those triangles is the original triangle, and one of them is the new one that we formed. We either made it larger or we made it smaller. Okay, anytime you have variables all alone like this right here, P with no prime up there, or apostrophe if you will, is always my original figure. Which means P prime is your new figure. We call it the image. I mean, think about it. If I took a picture of myself right now and I looked at the picture, would the picture look like me?
Yeah.
Or would the picture be the exact same size as me? Like if I took it with my phone right now, okay, would that be an enlargement or a reduction? So would the scale factor be more than 1 or less than 1? Okay, so what we need to understand is this. In the notes on the first page for vocab, to find your scale factor, which I always label as K, that's going to equal an image length divided by a corresponding original length. So help me out, kids. From the center to P prime, what distance is that? Do you agree that 4 corresponds to this distance of 12 right here? Okay. I have a question. If the blue triangle is the original and the red triangle is the image, is this reduction or enlargement, number 1?
Reduction.
It's reduction. So how do you find that scale factor? Well, you plug in your values. What is the distance from the center to the image point? 4. Okay.
Oh, thank you.
What's the distance from the center to the original figure? So my ratio is 4 over 12, which reduces to what?
Wait. No. 12 is the whole thing, right?
1/3.
But it's from the center to,
Oh my gosh.
right?
Yeah.
Okay, so the scale factor would be 1/3. Okay, is this going to be enlargement or reduction? Okay, you guys try the next one.
That was easy.
Okay, how about scale factor? What over what first?
You got the.
Why are you putting 25 up top?
Because that's the image.
Yep, that's the image distance. From the center to the image, P prime, it's how many units? 25. What are you putting on the bottom? Now, some of you might call that 2.5, and I'm okay with that. I'm going to tell you right now, it might be to your advantage to leave it as a fraction in lowest terms, considering what we're going to do here later on in the notes. So you could say that this is 2.5. I'd probably reduce this, or probably call it 5 over 2. Okay, is this enlargement or a reduction? Okay. Okay, that's going to definitely be an enlargement right there. Okay. How many had 5 over 2 or 2.5 or 25 over 10? Okay, that's pretty simple. All right, that's pretty simple. So let's take this idea and move forward with it. Guys, there's a coordinate rule for dilations. The coordinate rule for dilation says if a point P, original point P is x comma y, and that's the pre-image, we say pre-image like original. The word pre-image means original here. My G, fix my G. So that pre-image means it's the original point. Then it's image after a dilation centered at the what? And that's a big deal. It has to be centered at the what? This only works if you're centered at the origin. With scale factor K, is P prime is equal to K times X, comma, K times what? Okay. So, let's talk about this. In example 2, it says dilate the following figure. Now, if they don't tell you where your center is, you assume your center is where? 0, 0. If they don't tell you where the center is, assume 0, 0. Okay? So I'm going to blow this up. First of all, triangle PQR has vertices what?
0, 2, 1, 0,
And?
2, 2.
And its image after a dilation with a scale factor of what?
3.
Okay, does it say anything about the center in here? So since it says nothing about the center, we're going to assume, and we always use C for center as where? Okay, so here's the deal. What's the scale factor in this again?
3.
So let's get our image points. P is at 0, 2, so where's P prime going to lie? If what this is saying is take your original points and times it by your scale factor of 3. What would 0, 2 become if I multiply by my scale factor of 3? P prime would be 0, 6. What would Q prime become?
6, 0.
Careful. Q is what point up here?
3, 0.
1, 0. So 1, 0 times 3 would make that.
3, 0.
And then, okay, so let's just do this. They want us to graph the original in this, and then they want us to put these image points in there. And we want to see if this looks like a dilation by scale factor of 3. So help me with the original points, kids. Where are the original points? 0, 2. Oh, I screwed that up. It should be up 2, right? 0, 2. Next one. 1, 0. And 2, 2. Okay, so it looks like this. I'll do my best to draw a shape. You guys agree that triangle? That's a small one. Probably should label it PQR. Okay. Help me out, kids. What are my new points? 0, 6. All right, 0, 6. 3, 0. And I'll do my best to draw this shape. Gosh dang, son of a biscuit. Get a different color. How about this color? Make it fun. That's pretty good, isn't it? Pretty close. Hey, quick question. If I connected this point and this point, what point would it pass through? If I connected this point and this point, where would it cross? If I connected this point and this point, where would it cross? If I connect all the corresponding parts, where are those lines going to intersect at?
0, 0.
The center, right? Okay, the center. And mine's kind of screwed up. I mean, that's pretty normal for me. I screw a lot of things up.
But worthless.
What do you guys think? It's pretty easy, isn't it?
It looks
Oh, yeah.
pretty neat.
Didn't we do this last year?
A little bit. Now we're going to get more into it, but okay.
Do this last year.
All right. Well, if that's true, then do you understand how I got these points right here, kids? Okay. So let's go to the next example here. Let's move to the next example. Anybody need more time with that?
I'm glad you picked 3.
I like these graphs.
Which one? Oh, the 3s and 6s. Yeah. Hey, save example 4. I want you guys to try example 3 on your own right here. Okay. So go ahead, see what you can do with example 3. What's your scale factor this time? And you know what? I should probably back up on the last example. If I labeled my original points P, Q, and R, we better label our image points, right? P prime, R prime, and Q prime, P prime, Q prime, R prime. So let me go back and do that quickly. This point up here would be what on the top left? Wouldn't that be P prime up here? This would be Q prime, and this would have been R prime up there. So you might want to make sure you get those in there. By the way, I want to show you one more thing too. This is pretty cool. What's the distance up here from P to R? What's the distance up here from P prime to R prime? 6, right? 6 and 2. Those two distances correspond to each other. By the way, what's 6 divided by 2?
3.
What was my scale factor?
3.
Oh, okay. Keep that in mind. We're just comparing sides. All right, you guys try example 3 on your own, all right? Does it say anything about center in this?
No.
So assume what?
0, 0.
Okay. want to shoot P prime at me? 2 comma 3. Anybody want to shoot Q prime at me?
-2,
Negative.
2, 1.
And how about R prime?
1, -3.
Guys, do I need to graph these, or are you okay with this? Feeling pretty good about it? Again, if they say, hey, plot this, scale factor it out, no center in a coordinate plane, assume we're working from where? 0, 0, okay? Assume we're working from 0, 0. All right. So what I want to touch on here then quickly is example 4, and then 5 and 6 will go really quickly, and I'll get you going on online here in a little bit. But tomorrow when those kids are here, help me get them caught up on this a little bit. So a lot of your notes that are out there. By the way, what did this end up looking like, kids?
Triangle, another triangle.
Yeah, triangle inside one. So didn't the smaller one kind of go right inside of it?
Yeah.
Do they look like they're the same shape?
Yes.
Do they look like they're a different size?
Yeah.
So we would say the two triangles are not congruent, but similar. Okay, that's what we're doing here. Okay, so I think example 4 is kind of cool. It says using what kind of scale factor here? Negative scale factor. Okay, normally we don't use negative scale factors, but it can happen. And here's what happens with negative scale factors. First of all, let's graph FGH. Okay, so let's blow this up.
Change it to be negative.
Yeah, it's pretty interesting. Watch what happens here. FGH, what are the coordinates of F first? I don't have them up there. 3, 6. I'm going to go right 3 and up. 6. Okay, this is F. What's G? 3, -2, you say?
3, -3.
3, -3. Good. So right 3 down 3. And what's H?
6, 6.
Right 6 up 6. Ooh, I've got something wrong here, don't I?
Yeah, you have F.
F is in the
1
wrong
over 2.
spot, isn't it?
Yeah.
Okay, do I have it in the right spot now? Right 3 up 6. And the other one was 6, 6, you said? And this was H?
Yeah, H is 6, 6.
Okay, so I'll do my best to draw this. Give me a second.
Whoa, that's weird.
Okay, so here's what happens with the scale factor of negative 1/3. Okay, so F prime, let's just move this over here a little bit. Did it, yeah. Do I? Do I need to move them up?
Up 1.
Ah, gosh, I'm struggling. This looks like a 6 to me. That's a 5?
Oh, it's like a
That's definitely a 4, so 1 up would be 5. Okay. Hang on a second. Let me fix my whole art. You piece of trash.
Would've been much weirder.
All right, let's start over. 6, 6. Right 6. 1, 2, 3, 4, 5. LAD. Am I in the right spot now? Okay. And then the next one was 3, 6. Do I have that right?
Yeah.
Oh, my points doesn't go through the board.
Am I okay there now?
Must have done it.
Okay. Help me with my image points. F prime would become what, kids? F was originally what? And there's no mention of center here, so we're assuming origin again. So to find my new points, we just multiply by what? So what's negative 1/3 of 3? Well, what's 1/3 of 3?
1.
So this is going to make this negative 1 comma what?
2. Negative 2.
Okay.
Flipping me.
What's G prime going to be?
It's gonna be
negative 1, 1.
And how about H prime?
it's gonna be -2, -2.
Okay, so let me blow this up so I can plot this.
It's a flipped.
Yeah. Watch what happens here. I'm going to negative 1, 2, so left 1 and down 2. Is that right, guys? A different color. Negative 1, 2 is here. Negative 1, negative 2, I'm sorry. Left 1, down 2. G prime is left 1 and what? Up 1. And H is down 2, over 2, down 2.
Down to.
Yes.
Okay, I need to get some
That is
I need to get some labels to this, so hang on a second. Ooh. Pretty close. Okay, which point was this right here? What was the first point we plotted? Where was F at?
That's G. Wait, that one you're pointing at is G.
G? And this one here up here is G prime, is that right?
Yes.
Okay, what is this one?
F.
What's this point down here?
F prime.
What happens here?
H prime.
Guys, do they look like the same shape?
Yes.
What about the orientation now?
It's almost like you
It's like they've been
180.
180, right?
Yeah.
Okay, so they actually get rotated, if you will. They get like a rotation in it. Did anybody of you guys draw the lines at all to match them? Watch what happens here. This is pretty cool. If I draw H to H prime,
Looks like you're going through the order.
go through the origin,
Yes.
G to G prime. That's good.
X marks the spot.
Ha. Okay,
Yeah.
now it's just a bunch of scribbles and you put all the lines.
It's like it closes down to a point right here, and at this point, it's like it hits a mirror here, and it reflects it the other way.
Yeah.
So it's like almost like a, so
Rainbow or something.
it's weird.
Rainbow.
Okay.
Cool, man.
So negative dilation. What's it actually? It changes the size, but it also does what, kids?
Flips it.
Rotates it actually. Didn't this rotate 180 degrees basically?
Negative.
Yeah.
Watch what happens if I would rotate this.
But you can never just do it like 100. Well, you can never do it like 360 or 90, can you?
Isn't that like the same orientation now?
Yeah.
Hey.
Makes sense.
Yeah.
Okay, so it kind of it changes its size, but then it also rotates it. It's got a rotation of 180 degrees.
But yeah, but you could only ever change it by 180. You can never change it by anything else.
Exactly.
Unless the starting one was there, then it well, you said so. Yeah.
You'd be bending. Everything's on a straight line, and how many degrees are on a straight line?
180.
180. That's why it can rotate 180 degrees. Okay. All right, let's look at the last page here, kids. Last page is really simple. Whoop. So example 5. Finding a what? You already know how to do this. The scale factor is equal to, K is equal to my image length
Maybe I should say that.
How about you sit down?
over an original length. So it says you are using word processing software to type the online school newsletter. It says you change the size of the text in one headline from 0.5 inches tall to what?
1.2.
What's the scale factor of the dilation? Okay, what did you start with originally?
1.2. No.
Why am I using it?
We started at 0.5. 0.5 is the original, isn't it? And you went to an image size or a new size. Image is like a new size. You went to a new size of 1.25. So find the scale factor. What over what, kids? And when I divide that out, does that turn out to be 2.5?
I think we should change it to saying writing the note in the note as you go instead of the school newsletter
True.
because that applies.
Well, we could. Hi. Okay, so what did this divide out to be? 2.5. So scale factor here, kids, is 2.5. Hey, think about it. Is that scale factor more than 1 or less than 1?
More than one.
If you think about the example here, do we change the font to be bigger or smaller?
Bigger.
Makes sense that that font or that scale factor is more than 1 then? Okay, so that's all we're doing here, okay? All right, this is the one I like right here. It says finding the length of a what?
Image.
You're using a magnifying glass that shows the image of an object. Hi. Staples right there. There's a file back there. Okay, you read it out to Justin Parson. 4, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0.
Wait, I hope it's not. Can my mom filled it out to not that person?
Is that $4 million? Oh, dang. I can't make it on $40.
Oh, I'm sorry.
All right. Craft cotton is what it should be filled out. So just staple it, fill that out, put it.
I feel like someone that's not paying attention to that.
Or Fernando would definitely.
And then we'll just staple the catch.
Oh, you.
Okay, you guys ready? Last one here. It says you are using a what? Magnifying glass is going to make things look bigger. That shows the image of an object that is 6 times the actual size. So anytime I use this magnifying glass, it takes whatever you're looking at and it makes it how many times bigger?
6 times.
So the scale factor is what?
6.
Right? It says the image of a spider seen. So we're looking at this spider through the magnifying glass is how many centimeters? It says find the actual, meaning the original length of the spider. So if scale factor is equal to an image length,
So the image is the 13.5.
or the original, help me with this, kids. Do you know the scale factor?
Yeah.
What is the scale factor? Yeah, we're blowing things up by 6 times. Okay, so the spider that we're looking at, are we seeing the actual original spider? Are we talking about spiders?
Yeah.
Good. Better than snakes.
Really? That'd be hard. Really? I don't know how big it is.
Oh, I hate snakes. Hate them. Image length is 13.5, right?
Yes.
Do we know the original?
No, but we can figure it out.
So we're going to call that our unknown. So guys,
5 times 6.
so we would say 6x is equal to
13.5 times 0. Oh, wait.
So how many centimeters long is the original distance? What are you going to do?
Right,
13.5 divided by 6. Hopefully you get 2.25.
I'd do that.
So x equals. No, gosh, that's okay.
Is it 2.25? And it makes sense. Should if the magnifying glass makes things look bigger, should the spider be smaller actually or bigger than what we're seeing through the magnifying glass?
Why are we looking at a spider?
That's a good question. I'd be killing spiders.
Yeah. It's probably already dead.
No, except.
We're just looking at it.
That's very harmful.
Okay.